So first thing is that slope is a rate. That's what we were just talking about, right? A rate is two numbers compared to each other. It's usually written as a fraction. So the numerator is being compared to the denominator. So over here we have slope represents the rate of change. Slope should be written as a, oh geez, that's not good, fraction. Like I said yesterday, I'm getting used to this. So I'm sorry, my handwriting is really bad. That says fraction. Can all read that? And we want to write that fraction in its simplest form. So that's why we were looking at that in the warm-up, why we were simplifying fractions. I don't know if this is such a good idea. Maybe I will just use this. Simplest form. Simplest form. Can you guys read that? No? Yeah. Simplest form. Simplest form.
I thought the T was like a plus sign.
Yeah. Well, I'm just bad at writing right now. Clear annotation. Yes. Let's try again. So slope should be written as a fraction in simplest form. Okay, so like what we were saying, a fraction, a rate, is made up of two different numbers. One's the numerator, one's the denominator. When we're looking at the slope, the numerator tells us our rise, and the denominator tells us the run. The rise is our vertical change. Run is our horizontal change. So when we're calculating slope, we're going to look at the difference between y values. Remember, y is our vertical axis, whereas the run is calculated by the difference of our x values. Remember, x-axis is our horizontal. So here I'm going to write the slope. Usually it's denoted by the letter m. And the rise is going to be one y value minus another y value. Do you guys know what these the 1 and 2 means here?
Exponent.
It's not an exponent. Exponent is up. That's called an exponent is called a superscript.
Isn't that like y to the second power?
No, that's the exponent. That'd have to be a superscript though. That'd have to be up. This is called a subscript. Do you know what it means? So what it's just, all it's saying is it's saying like, this is one y value and this is a second y value. So like, if I didn't know any of your names and I was trying to organize where you were sitting, I'd have student 1, student 2, student 3, student 4, student 5, student 6, student 7. Okay? That's just like an easy way of kind of organizing everybody if I don't know your names. That's all that these subscripts are doing. They're just kind of organizing our different values. And every y value, if that's representing the y coordinate of a point, it's going to have a corresponding x value. So up here I have the change in y. That's my rise. That's the difference vertically. And in the denominator, I have the difference in my x values. And do you see how there's x2 first, y2 first, and then x1 second, y1 second? So that's saying that these two values correspond with each other. That's 1 point. And then this is our second point. Okay? I think it'll become more clear in a minute. So, the slope of a line can be determined from a table by counting units on a coordinate plane or by subtracting the coordinates. Okay, so when we were looking at these shapes, we were counting the units on the paper, right? And that's how we were determining the slope. We were counting the vertical change and dividing it by counting the horizontal change. So we can determine the slope of a line by counting units on a coordinate plane, or we can use this formula and we can subtract the coordinates, or we can find the difference. Okay. So what we're going to do next is we're going to find the slope between between 2 points. I'm going to do the first one, and then I'm going to have you guys do the second one. So, like we just said, we can subtract the coordinates to find the slope. And let's just pull this up so we have it. We have our formula up here. So again, slope is equal to the change in y, the difference between y coordinates, divided by the difference between x coordinates. And we have to make sure that they're written in the same order. So I'm going to do this one. So I write n equals change in y. So I take one y coordinate. Let's just remind ourselves, an ordered pair is always written like this. In parentheses, we have our x coordinate first, our y coordinate second. So the second value here, those are my y values. I'm going to take 4, and then I'm going to subtract -2. I do minus -2. That's my rise. That's the change vertically. And then my run will be, I have to use the corresponding x value. So I start with 4, and then I subtract 3. So in the numerator, I have 4 minus -2. What happens when I'm subtracting a negative number?
Wouldn't it be 2? 4 minus -2 is -2. Wait, what? Yeah.
So when we subtract a negative number, these negative signs cancel out, essentially.
So it's just 4 times 2?
Not 4 times 2, not 4 times 2, it's 4 plus 2. 6, yeah. So that equals 6. That's my numerator, that's my vertical change. And then in the denominator, I have 4 minus 3, which is
1.
1.
So 6.
Yeah. So 6 is my rise, 1 is my run. However, we learned earlier, we want to be able to write our slope in the simplest form. So any fraction that has 1 as a denominator is just equal to, Ralph just told us, is just equal to what's in the numerator. So our slope is 6. But what's my rise? What's the rise here?
6.
Yeah, and what's the run?
4.
Perfect. Yeah. So my vertical change is 6. My run is 1. And I just want to point this out. And I want to point this out. So So I did 4 minus -2, and then I did 4 minus 3, right? I could also do it the opposite way. So I could do -2 minus 4. Let's write that down. Could have -2, where should I write it? Do it here. -2 minus 4 divided by 3 minus 1. So -4, no, what am I doing? 3 minus 4. Sorry. 3 minus 4. So -2 minus 4 is -6. 3 minus 4 is -1. -6 divided by -1 is still 6. Okay? So it doesn't matter what order you do it in, as long as you make sure that the corresponding coordinates are in line with each other. Does that make sense? Yeah? Okay, I want you guys to do number 2 on your own then. Well, you can do it with the people at your table if you need some guidance. But work on number 2. All right, raise your hand if you're able to find the slope for number 2. Raise your hand if you got the slope for number 2.
I'm in the process of it.
Okay. You want me to get you started?
Okay,
Yeah.
so when we get the two numbers together, like the 2 on top and the 2 on bottom, what do we do after that again?
So you want to subtract the 2 numbers in the top and subtract the 2 numbers in the bottom.
So the first one brings 8, that is both in the top, right?
Yeah. So in the numerator, okay, what are my x coordinates? 6 and -8. So we can either do -8 minus 6, or we can do 6 minus -8. Same difference.
Either way, they're 14, I think.
So the sign might change, but it will all work out in the end. So which do you want to do? 6 minus -8 or -8 minus 6? Okay, so we've got -8 minus 6. That's our vertical change. That's our rise. That's in my numerator. What's in my denominator? What are my y coordinates?
0 and -1.
0 and -1. What order do I have to subtract those in now?
0. Oh wait, -1 goes.
Yeah, I have to do -1 minus 0 because I did -8 minus 6. So I started with this point and then I went to this point. So again, in the denominator, I have to start with this point and subtract this point. So I go -1 minus 0. So what's my numerator? What's -8 minus 6?
14.
Not positive 14.
-14.
-14.
They both are in the equal sign that I'm not equal sign, the plus sign.
So you did it the other way. You did 6 minus -8. And in that case, they do.
Okay. So I'm doing it good my way?
Yeah.
The other way?
Yeah, you were doing it fine, I think. Okay, and then what's negative 1 minus 0?
Positive 1. Okay. Negative 1.
Negative 1 minus 0. If you owe your friend $1, you have negative $1. But if you don't owe them anything else, then you still owe them negative $1, right? Just negative 1. If you subtract 0 from something, it doesn't change the value of it. So I have negative 14 divided by negative 1. You know what I did? What did I do wrong here? I did something wrong. No, I did something wrong. This is a super common mistake.
You get to add a symbol?
Nope.
You didn't get the numbers on it, okay.
What's my x coordinate and what's my y coordinate in this point?
Oh, it's back in the other, right?
It's backwards. I put x on top. I put x in the numerator and y in the denominator. You see? We need to have our y coordinates in the numerator, x in the denominator. I did it the other way around. So let's rewrite that. So what's my y values? Negative 1 minus 0. What's my x values? Negative 8 minus 6. So now I get negative 1 over negative 14.
But isn't the same as, that's not the same as negative 14 over negative 1, right?
No, very different. Yeah. When I have two negatives, when I have a negative in my numerator and a negative in my denominator, what happens to the fraction? It becomes positive. So my slope here is going to be 1 over 14. Okay? Let's go on to this next piece. So we're going to plot a line that starts at the origin and has a slope of negative 3. And we're going to label that line A. So where is the origin? What are the coordinates of the origin? 0, 0. So that's going to be right here, right in the center where it says O. So origin is right there. So plot a line that starts at the origin and has a slope of negative 3. So what is my rise and my run if my slope is negative 3? Yeah, if that negative 3 is the same thing as negative 3 over 1. That's messed up 3. So what's my rise and what's my run? Yeah. So my rise, again, is my vertical change. Since it's negative, I go down. So from the origin, I count down 1, 2, 3. And then my run is 1. So I go over 1. And then I just connect those 2 points. And then I can kind of extend it in either direction. And again, that's going to be A. Line A. And now I'm going to plot a line that starts at 0, 4, and has a slope of negative 3 over 4. And that's going to be called B. What's my x coordinate and what's my y coordinate of this point? 0 is your x. Yeah. So 0 is my x coordinate. That means I don't go left or right at all. I stay on the x-axis. And then 4 is my y coordinate, so I go up 1, 2, 3, 4. So I start there. And my slope is negative 3 over 4. So what's my rise?
3, -3.
And what's my run?
1. I mean, 4.
4. Yeah. So from here I go down 1, 2, 3, and then over 1, 2, 3, 4. And I connect those 2 points and can extend it in either direction with those arrows. So remember, these lines that we're drawing, obviously I can only draw this much, but in theory it goes out infinitely in either direction. That's what those arrowheads mean. They keep going. So this is line B. So let's talk about this. Steeper slopes have greater absolute value. Do you guys know absolute value? Is that familiar? Yeah? Kind of? Absolute value. Does that ring any bells?
Mm-hmm.
Yeah? How do you write absolute value? Do you write absolute value like this? With those 2 lines. So the absolute value of 6 is what? No, can't remember. So absolute value, it is exactly what it sounds like. It's like the actual value. Doesn't care about negatives or positives. It's just the value of that number. So it's 6. What's the absolute value of -1?
1.
1.
Oh yeah, wait. Never mind.
The absolute value of 2/3.
What was that one thing we learned where it was like, if you had 2 with like a specific term or like a word or something, and then it would be like -2 for the opposite?
The reciprocal.
Yeah.
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 Yeah. Yeah. Absolute value of -6/7.
6/7.
There you go. Yeah, just 6/7. So steeper slopes have greater absolute value. So when we looked at these shapes in the beginning, we had C was the steepest. That slope would have been the greatest, whereas F had the smallest slope, smallest absolute value. Let's go. Do that. Let's do this. So we're going to find the slope of each of these lines. Okay. Let's look at this one. Remember, slope is rise over run. So my rise here would be this distance. And I can just count that out. That's 1, 2, 3. And then my run is the horizontal distance, which is 2. So what's my slope?
3, 2, 3.
Both. Combine them together. Remember, we're doing rates.
3 over 2.
3 over 2. 3 over 2.
Combine them together.
Yeah, put them into a fraction. 3 and 2. Remember, rate is the comparison of 2 numbers. 3 over 2. How about this one? Someone count it out.
6 over 3.
Not over 3.
2.
3 over 2. 2, 4, 6. Yeah. So that's, and is it negative or positive?
Negative.
Negative. Negative, because we go down and then over. So any negative slope is going to be going down when we're looking at it from left to right. It's going down. So yeah, it's -6 over 2. What does that simplified too, because remember we need to write our slope in simplest form. Negative 3. Negative 3. Okay, and then how about this one? What's my rise? 2. What's my run?
5.
Count again. 4. So what's my slope?
2/4.
2/4.
4.5.
And is it positive or negative? Positive, because it's going up from left to right.
Could be half 2, right?
2/4 simplifies to what?
Half.
1/2. So my slope is 1/2, or 1/2. Okay, and then a couple of special cases. So we could have a horizontal line, or we could have a vertical line. A horizontal line is, like this, like the horizon. And that has a slope of 0. And then a vertical line, straight up and down. Vertical line has a slope, we call it undefined. So the vertical line has a slope undefined. And from these two little notes, remember, up or right, those are going to be positive movements. Down or left is going to be a negative movement. So down or left is going to be negative. Cool. Great, let's go on to the next page.
Wait, what's that?
Oh, sorry.
What was the one the slope is a vertical line is what?
Undefined. Undefined. Okay, so I want you guys to try this. Graph 4 different lines. So just draw 4 different lines, all with negative slopes. All of them should have negative slopes. Negative lines go down from left to right. Show each slope and compare the steepness. So draw 4 lines, all with negative slopes, and then find the slope of each line, and then think about how they compare to each other. Which one is steeper than, which one is less steep than. Okay? And you can work by yourself, or you can work with the people at your table.
That's how it is, bro.
So,
That's literally what the line looks like. I swear.
Nope, not that. It's that. So if you're looking at it from left to right, like you're reading a book, the line needs to go down.
You go.
Yep. 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 So, yes.
No, that's how it is. It goes down, it's like that. Yeah, from left to right. Not from left or from middle to left.
Right.
Wait. We're doing it like that. I thought we were drawing like a line. Like.
So you're drawing 4 lines with a negative.
Oh,
So remember, vertical line is an undefined slope. Horizontal line has a 0 slope. But I think I see where you're going. If you connect this point and that point, so you have a negative slope. There you go. There you go. So that's one.
I told you that's how Bro, you literally drew a 6 inch line. Literally like this.
So negative slopes. Negative is down from left, like when you're reading. If you're reading from left to right. Yep, exactly. So draw 4 different lines with negative slopes.
No. Wait. All right. That was all good. Dude, that's what it's supposed to be, right?
And now to show you how you're going to find the slope. So, yep, exactly
doing this now.
how far is that?
Y'all walk like that sounds.
Not 3. So remember, we're comparing 2 numbers together. The rise is in the numerator. The rise is in the denominator. Yeah. Yep.
Because you drop 4. No, I think that's the other 2. That's why I do the 4 there.
Yeah, that's fine. So it's going to be easier if you like draw the line so that they, yeah, so that you find,
Yeah, okay, that's what right there.
one third.
You know what I'm saying?
So you can come.
Alex, look, you know, I'm showing you how it will work. There's one line right there, there you go. That's 2 lines right there, bro. There's 3 and 4. Oh, okay. Oh, good. That's the people that are with us. That's how it is. That's how it is. Awesome. So, there you go. Yeah. I know this is making a lot. That's long triangle. No.
So remember, these are negative slopes. So the slope that you write down should it be positive or negative? Negative.
Are both of those negative? Or all 4 of those negative?
So these 2 are negative. These 2, this one, right?
So the right side is positive, but the left side is positive.
Yeah.
Oh, it's okay, because I got my full thing.
No, you did it. So these are both negative. And these 2 are all positive. They're all supposed to be down. So literally,
I want to draw on this side.
For the past few years.
Oh, I can go above this one?
Yeah.
Oh.
Not anywhere in here.
Just on the right side.
No, anywhere. We have the left side too, but it just has to be a negative line. It doesn't have a positive line. I know.
Oh, because it's going from left to right or up? Wait, so
It's going
here?
up. When you look at it from left to right. If you look at it from right to left, it's going down. But we're looking at it from
Like
left.
this one's negative, this is going down.
Yes.
Oh.
Okay, and what are the numbers that you're looking at?
1, 2, 3, 4.
Oh, you're just naming.
Yeah.
So we're going to try to do we can do one of them. So I'm going to steal that.
Can we do this thing? This thing looks fun.
No, I want to do that one last. We're going to do this.
What you call it?
Eventually when you're done.
Are you done with that? Yeah. Are you done with these? Oh, I'm done with these.
Cool. Okay, we have one more thing to cover on here, which is down at the bottom. So first, slopes will be represented with fractions. Steep, that's what it says. It's steep slopes. Steep slopes. Steep slopes will be represented with fractions with a greater absolute value. Absolute value. So it's just saying the same thing we covered on the last page, was that the absolute value, the greater the absolute value, the steeper the slope. Okay, and then last thing we want to do is we want to sketch a sample of each of the following types of lines. So we have a positive slope, a negative slope, a zero slope, and an undefined slope. So positive slope, again, from left to right, the line is going to go up. So it's going to be like that.
Wait, so the zero slope is like down the middle, right?
Hold on, we'll get there. Negative slope from left to right is going to go down. Zero slope is just straight. And then an undefined slope. No. What's an undefined slope? Vertical, yeah. So I have this little guy over here, Mr. Slope Guy. You can draw this down, write this down too, because this is helpful. You can draw a person, a face. A positive slope is going to go up from left to right. Negative slope is going to go down from left to right. Undefined slope is our nose, that's the vertical. And then the zero slope is his sad mouth. Kind of a sad looking guy, isn't he?
Whoa, you got vertical.
Okay, two last things to do. We want to order these from steepest to least steep. Remember, the steepest has the greater absolute value. So what is the steepest slope here?
4.
No.
1.
There's 1/3,
Oh,
3, 3/2, and 3/4. What's the steepest slope?
3/4.
What's the biggest number?
3.
3.
No, I thought it was saying 1. I thought that 2. I thought that 4 was just 4.
Yeah, it's okay.
I didn't see it, right?
What's the next biggest number?
3/4. 3/4?
No.
3 seconds. Or
3/2. 3/2. And then what comes next?
1/3.
No.
3/4.
3/4. And then 1/3. Okay.